Nice.
Not what we expected. So we're back. Part 2 of the $1.6 million pool house. This place is gorgeous. White oak, plaster, vaulted, 8-person in-floor hot tub back there, locker rooms and showers, a mechanical room that's as big as a small flat in California, and this lap pool. It's gorgeous. Absolutely gorgeous. So the big cutover is today. We're probably going to have 3 or 4 utility trucks out front. We're going to be going from the existing 400 amp service on the house and temporary power at the garage to the final, long-awaited, 18 months in the making, 1,200 amp designated service for this complex. Let's cry together, let's laugh together, let's bust some knuckles. Let's go. So we've got the AES line crews here, 2 of them, and we are energizing the 1,200 amp service to this residential property. Yes, 1,200 amp service. This is so big they couldn't pull it off any of the adjacent infrastructure. We had to go half mile down the street. The utility company literally tied into primaries a half mile down the street. Directional board underneath the streets, one after another, turned a right angle and set a dedicated transformer for this property to accommodate the $1 million pool house, the detached garage, and the McMansion behind me. If you recall, we've been here before, and we're picking up where we left off with a scheduled utility cutover day where the overhead power goes away. Underground power gets energized. It's time to make tracks. Let's go. Is that the fuse in the top left corner that you used to de-energize real fast?
Oh, on the left-hand side there?
Yep.
Yeah. Yeah, we can pull that out, and that basically drops out the secondaries.
Nice.
So.
Very cool. And so we've got CT metering, which the gray ovals top right, those are our CTs.
Yeah,
underground to our meter.
That's an unusual installation. We've never seen one done like that. So this whole thing is really quite interesting.
Okay. And what would you expect to see there?
Well, normally they're not on a single-phase pad. We have CTs and 3-phase pads all the time, but to have one in a single-phase pad is interesting. So normally it wouldn't be there. So this is the first time I've ever seen this kind of installation.
Okay.
Which is kind of fun.
And is that because of, you don't usually have 1,200 amps to a residence?
No, a lot of the big houses have 1,200.
Okay.
But they just have different locations, multiple places where they come from.
You might have a 400 on the carriage house, a 400 at the house.
Yeah.
Yep.
So, but that's the interesting thing about this one. When we first tried to figure what was going on, it's like, this is new.
Right. Yeah.
Is it something you guys are trying to pioneer?
That's a good question.
And I'm trying to figure out how we got to here.
No, I didn't have anything to do with the arrangement of the actual transformer and CT metering.
Right.
Absolutely nothing to do with that.
Okay.
Just a power request that took about, probably 16 months to work through with the utility before collectively we arrived at this situation.
Yeah, interesting. Okay. Yeah.
Those are some massive terminal bars.
You're talking about, well, here? Yeah. Where the secondaries are?
Yeah.
Yeah, that's
1, 2, 3,
pretty
4,
standard
5, 6.
for us.
Okay.
It gives us the ability to, get quite a bit of load in there.
So effectively, front side of this is the junction box. Back side is the transformer windings.
Yeah, pretty much. The primary coil is back inside there underneath that enclosure, which we can't get to, which is good.
Right, yeah.
We don't want to get to that. We've seen it when we've blown them up. That's not good. But yeah, primary comes from the riser 2 blocks away almost.
Okay.
And that comes up for this side. This is just an arrestor because... Like
a surge arrestor?
Kind of, yeah. It's a dead-end arrestor because we've dead-ended it here. That phase comes down to us and stops right there. And so if you just left it open or covered, you could have another issue. So, because we have dust covers, this works as a dust cover plus also a lightning arrestor.
Oh, right.
So it just tries to protect the transformer.
Right.
So,
and I see you've got a grounding rod through here.
Yeah.
grounded to the cabinet of the transformer.
Yeah, we ground pretty much everything. I mean, I'm sure you know.
Light poles.
Everything has to be grounded, you know, and so it's just, you got to get it pat the ground, you know, shunt that thing as fast as you can.
Yeah.
I mean, even when we have overhead or underground faults, we want it to hit something quick and knock it out, you know.
Yeah.
But that's what this thing is doing for this one. If something happens, a car hits that pole down there, and neutral gets into the hot phase, then you've got something really bad coming your way.
Right.
In a split second, you know. So you want to get that thing to ground as fast as you can.
So this is the last big project that we've got to complete before we're ready for the lineman this morning. This is the aluminum cable that's coming in to our 100 amp disconnect. We're keeping the overhead EVX service. This is 100 amps to the meter and then 50 amps to a NEMA 1450 outlet strictly for electric vehicle charging. And that's a phenomenal rate. They're gonna fill the tank of their Tesla Model X for $5 through this service by charging during off-peak overnight hours. So this set of conductors is going to come into a 100 amp disconnect, and then we're going to have SER cable feeding through the structure and to the existing panel that's in that front left corner. This is a detached garage. AES typically only hits each structure at one location, so we've got our disconnect and our meter at one location. So we're spacing these disconnects out real quick, 3/4 inch, to accommodate a better finish with the siding.
Yeah, when do you anticipate approximate power shutting off and then being re-energized?
Good question. I'm thinking we'll take it offline in about an hour and have it re-energized. It sounds like to the transformer within 20 minutes after that, but probably to the house, because we'll have to land the 2 feeders, probably maybe an hour after it's de-energized. All right, so you've got 2 options in water sealing this disconnect. You can go around the perimeter with a lot of caulk and a big gaudy caulk seal, or you can just caulk the penetrations right around the hole into the house and each screw hole individually. Keep a real tight and good look around the disconnect. Man, that is by far an at-large. If you work at Jefferson Electric, just caulk the penetrations, not the perimeter of the equipment. Please, please. There, that way we get some good solid grab. Without a block on the backside, there would be no grab, and I guarantee those fasteners would come loose. Now check this out. We have 2-inch Schedule 80. That's they call it extreme heavy wall at times, printed on the pipe. We've got a bell end on the end of this pipe to smooth the wire entry. That's code. The pipe is going to be a minimum of 12 inches below grade, protecting this direct burial cable. And this is always a little bit hard getting it in. Chance we'll have to loosen up the disconnect. We'll see. Got plenty of cable. Tell you what. Yeah. Let's go ahead and cut it right there. This is a bad time to be cutting cable too short on cutover day with 150 feet of buried. Bad time, bad time. So we've communicated with the homeowner about the power outage, and man, we've under-promised and over-delivered. We gave them the expectation for 12 hours the power will be out today. We might be able to get it down to 1. Things are really lining up quite well right now. All right, Cliff, joint effort to get this conduit in. Somebody called out in one of the videos recently that minis are not permitted for PVC. And that's an interesting thought. I could see where they're coming from, so I looked it up, and minis are listed for conduit supports. non-specified type of conduit support. I will say that any support fastener on PVC pipe intentionally should be loose enough that there is the ability for the PVC to expand and contract. It's got to accommodate thermal expansion. We're using fuses at all of these structures because the utility service to this address is so incredibly robust. These fuses are rated at 200,000 amps fault current, interrupting capacity. That means if there is catastrophic failure, these fuses are going to perform much better. They're going to outperform the standard circuit breaker, which will be rated to an available fault current of 10,000. 200,000, 10,000. And so we've taken a precaution to make sure that if something should fail catastrophically, we have the interrupting capacity to disarm it without enclosures physically rupturing because of the fault. So that's what could happen, is that this becomes a massive molten steel flying through the air. Again, only under catastrophic situations. We're not talking about tripping out a 20 amp circuit. We're talking about a direct to ground fault, hot to neutral, hot to ground, something like that. So fusing over circuit breakers for maximum protection. Fuses like Edison fuses and a fuse box is dated technology, but and it didn't restrict people from tampering. But what a lot of people don't understand is fuses outperform circuit breakers in every category, period, every category, except replaceability. Right, that's the only thing. A circuit breaker, just click it back, click it off, click it back on. A fuse, you have to replace the entire component. That is the only way in which fuses do not outperform circuit breakers. They're a little harder to install sometimes too. Come on. There we have the indication on the wire amidst all of the nomenclature. Phase B. This is a B phase conductor. Each one is marked. Phase A, phase B, phase C. Comment, aluminum alloy conductors often do not actually require no locks, but it's not easy to detect and discern which ones are alloy and which ones are aluminum, which ones are required by manufacturer, which terminals, etc. So the no locks doesn't hurt. The local inspectors always want to see it. Technically, sometimes you don't have to install it, but as a standard and a policy, we put the no locks on there and we wire brush it in. I should say as a best practice, just without fail. Without fail. Labeling is real important. Ran into this situation the other day. A solar installation had been performed at a customer's barn. The barn had an older panel and there was a legacy label because the breakers kind of moved around. A small sub panel in the barn. There was a legacy label that said Maine. It was kind of deteriorated and not real prominent. There is a more prominent label installed that said solar electric, caution, solar electric breaker is backfed, etc. Clearly identified, large white lettering on a red field, nylon label. However, that little main label did not get removed. And what happened was a handyman was working on that barn, went to install receptacles, saw that main label, looked right past the unfamiliar large 5-inch long white letters, red field that said something contrary, flipped off the inverter, the solar inverter breaker, thought the whole barn was de-energized, bad assumption, went and started performing work on a receptacle without test equipment and got shocked. And so, gotta get labeling right, gotta remove the legacy labels if something changes, and use test equipment every single time. I'm going to torque down these terminations. We've gone over that, talked about it. I'm doing the tighten, loosen, tighten method in order to make sure that my stranded conductors get fully seated into my terminals and I have a high conductivity connection. Now what I don't really like about this is the lack of space. Man, see, this conductor's got a nice smooth radius. This conductor's tight. This neutral conductor is going to be jammed in there. It's going to be real tight, real tight. Don't like it. The switching mechanism is on the right here. Is preventing me from coming up here. I've got to make sure that everything moves freely. And so I am going to stick to the left side to prevent congestion or malfunction. So guys, question for you. Is there a better way other than a utility knife for stripping like number 1, 2, 3 conductors? This is a URD, so it's a heavier jacket. I know Klein makes this fantastic tool for 2 watt through 250 KC mil where the blade is protected. Insert the wire, twist. But what about this? What do you use? Post in the comments. So you may ask, why 100 amp disconnect right next to a 100 amp meter where there's no wiring connection? The answer is this. This meter is for the EVX service. It's an overhead service from the pole. It services nothing but electric vehicle charging. It is specific to our utility and it provides a fantastic rate. Tesla Model X, fill the tank, $5 overnight with this EVX meter. This service is for general power to the garage. It's a 100 amp from the new utility transformer. We've co-located them so that anybody in the event of an emergency, a firefighter, lineman, or otherwise, will see that this is a service disconnect, emergency disconnect, and that this is also a separate service to the same structure. 2 services, 1 structure. So I'm actually cutting off this aluminum ground. I can't use aluminum for grounding to a ground rod because it'll corrode in the soil. I've got to use copper. For 100 amp, that's number 8 copper. The reason this grounding conductor is here is because in the original analysis, we thought we might put the disconnects at the transformer and carry 4 conductors to each structure. So we buried it just in case because we didn't have total clarity from the utility company. However, this grounding conductor that comes from the transformer at this point is no longer needed. So I'm cutting it off, shoving it out of the way. It's dead to me. The 400 amp equipment, 600 amp equipment is so expensive. So we almost always build in 200 amp increments and it's just cost effective. But this is a pool house. You should poke your head in there real quick. It's beautiful. Check this out.
My dad does pool for a living.
Oh yeah? I think we have to. So it's an indoor pool. It's all plaster and white oak.
I don't even get in there that way.
You can't go through, but you can see it. It's all plaster and white oak. There's a hot
pool in there?
Yeah, this is a pool house.
Oh, I didn't know that.
It's a $1 million pool house.
Right here?
So they've got heaters and dryers and circulators and pumps of all kinds. So they wanted 600 amps out here. So they bought the house like 7 years ago, probably for like 350K is what Zillow said. Mm-hmm. Added a $1 million pool house, 1200 amp service, like.
240, what you got?
Yeah.
We should have 120, what you got?
120.
One more time? Yeah? So before let's do that on this one right here. Let's start off with a 120.
Yep.
Start off another 120.
Yep.
240.
Yep.
All right. Last but not. It actually is the last one. 240.
Yep.
120.
Yep.
120. Good man.
You guys will be slightly ashamed to call me your friend. You'll notice on the terminations, we were struggling to purchase 350 KC mil single mechanical lugs.
Yeah.
They're like, oh, they're 4 weeks out. We're like, well, we're doing the work in a week and a half.
Yeah.
So we trimmed them down.
We do that.
Yeah.
You gotta make it work.
Yeah.
Sometimes you gotta make it work.
Yeah, sometimes
Yeah.
you gotta make it work.
AES, the utility company, is complete. They're out of here. Their work is done. Everything's up to us now. They've disconnected the old service. The old service is this large feeder into the main breaker number 1 and this feeder into main breaker number 2. I'm going to be disconnecting that and disassembling the old service right off the side of the house. New feeders coming from the new service and the new disconnects are right here. I'll be landing those in the panel in the same fashion they were landed before. There's one change that's going to take place. These were the main disconnecting means before. They're not anymore. So it's incumbent upon me to separate grounds and neutrals in each of these panels. To do that, we're going to add a grounding bar across the top of each panel and pull the grounds out of the terminal bars and land them up top. In addition, we're also going to pull out those green screws that bond the neutral bar to the steel cabinet in both panels. Note, this one actually never got landed. So that's an original boo-boo, but it's good for us now. Meanwhile, before starting work, I used my digital multimeter to confirm both of these are dead. You never know when something on a property is getting energized from someplace else and it's backfeeding into your main equipment. So that's been confirmed. Cliff is working in the garage. What he's doing is he is cutting over power from the old feed, which is a 40 amp feed right here, to the new feed, which is the new 100 amp service. So we've upgraded their detached garage from 40 to 100 amps. Side note too is they've got this direct burial cable flying free through the air. So I will be setting that in a junction box, putting it out of the way. It's dead and I'll be labeling it as such. All right, you can do almost anything in the name of temporary as long as it is legitimately temporary. I'm gonna make a decision right here. I'm a few parts short. It's time to run to the nearest supply house and grab those parts. But let me tell you what I'm gonna do. I haven't landed the ground. Grounds and neutrals are still bonded to the cabinet, to the main neutral or grounded conductor. I'm gonna go ahead and energize the disconnects, which have already been tested for voltage. I'm gonna energize these panels. I'm gonna give everyone in the house some power. Let the AC bring the temperature down, so get a little hot and sweaty in here. And I'm gonna be back in about an hour. But this ground is gonna be floating in the meantime. Tell me what you think about that. Floating in the meantime. Looks good. Good, good, good. All right, appreciate it, that's it.
All right.
Thanks, bye.
Bye.
Always pays to do a visual inspection. Just looking over the terminals. That one almost seemed a little further out, so I was just wiggling that conductor to make sure that I didn't see any visual movement there. But I'm gonna turn on the power. Always advise putting the cover on and or looking away, just in case there's an arc flash. You never know if you might get bits of exploding copper in your eyes or face. So I put my hand on the breaker, turn away. There it is. Same. Hand to breaker, turn away. Basement lights. Like it. All right, so far so good. Hey, general contractor is adding a sewer line from the pool house, tying it back into the house, and we uncovered this PVC conduit. The natural question is, what is it? It's obviously electrical, it's gray, and we've got 3 or 4 conductors inside of it. I'll tell you what it is, it's perfect timing. It's the old feed to that corner of the garage right there, that's what it is. So I was gonna cap it inside, but instead I'm just gonna knock it out of the way, rip the wire out, cut it off flush with the edge of the trench, and let these guys go about their business. Another day in the office, as they say.
Nice.
Not what we expected.
There's the spark. Sawzall still works, right?
Man, it's coming out right there. It's going right there. I've already unlanded that breaker. What else could it be? It's a slightly smaller conduit here, but it's not uncommon for something to change sizes. So I'm gonna go take a look inside, see what I can find exiting the house right there. I wonder if there's a chance Cliff tied it back in the garage and didn't leave it isolated. So it's actually getting juiced up from that end, not this end. It's possible. Let's go there. Let's go there.
Is that rolling?
Well, that's it. It's capped. So there it is, right?
Yeah.
And the garage feed definitely exits the house right here. I still think this is what it is. And I think that this, when something arcs, it's louder than that.
Right.
So I think it's actually just the spark. The garage feed is this one right here. There's nothing else. Ooh, okay, that doesn't go underground. This is the only one, right, that you see that goes underground?
Yeah.
And that matches where that is. And look at that. Unfortunately, we don't want to take away any more here. I'm thinking it was just a spark and not an arc. Because if it was an arc, you hear that. I mean, it's like a bang and your eardrums ring. It caught us by surprise. But let's just, at this point, we can, well, they took it. Let's see if it's still live or is live. So it's dead now. I still kind of think it is. There's 1, 2, 3.
Sorry.
1, 2, 3, 4. Okay, so regardless, to repair it, if it was something that we needed to keep, we'd have to cut it clean, splice it, pull the wire out. I say we cut it clean, pull on it, and what we might experience is those wires come ripping out of there. Those wires will pop around in there and bounce back and forth.
Yeah.
Make it hard to... Man, that just looks like it.
Yeah, and there was a lot of spark on that cut too. Same as the first.
Yeah. Something else, provisional. It's gotta be it. I don't even know if we can pull it. Let's try one. I don't think it'll go by itself. Nope. Well, one thing they may have had is a switch in the house that controlled these lights, and I don't know where that was introduced. But there could be a switch in the house that controls those garage lights.
That's exactly what it is. I saw it. I was looking at the breaker, at the panel labels a minute ago. That's garage light. It's gotta be.
So that would have been nice to hang on to. But we can do it wirelessly, which I think is going to be more cost effective than this. Even repairing and repulling.
Sure.
So we can get some insight from the homeowner about where that switch is and what they want to control and if they want it set back up that way. Or maybe we put an automatic control in there. So where that feed was, interrupt it, put in an automatic timer, connect it to the breaker, and then all the garage lights come on at dark, turn off, or photocell, whatever.
So photocell on it, yeah.
If they don't need override control here, we can automate it there. Or we can do it wirelessly from here to there.
Okay.
But either way, I think it's a better option.
I like it.
So I'm gonna cut it there, and we're gonna wash our hands, literally.
You better.
Alright. I'll put all these in a J box right there and just label it. I'm gonna add a ground bar up here, terminate the ground to, and then all of these grounds to that ground bar. All of them are going to be pretty convenient, I think. I think everything will reach except these two down here. But they've actually already got a jumper in place, so that's not too bad. So that's that. Covering up the main terminals to minimize the amount of exposed conductive surface. Now you can still poke through this electrical tape and get shocked, but these are not insulated gloves. So the outside conduit, the 2-inch PVC that was right through the sewer trench, that was carrying our garage conductors as well as a switch leg. This guy right here, a black 14-3. That 14-3 was carrying a switch leg from the house out to the garage so that in the house they can control the lights on the garage. And that's a fairly common practice around here in older garages. We're not going to clean up and repair that conduit re-pull wire. What we're going to do is give the customer two options. One option is use a wireless switch control from the house to the garage. Second option is use an automatic control in the garage so they don't have to worry about switches anymore. And if you've seen enough of our videos, you know that's definitely my preference. Automatic controls to systematize the routines of life. Simple, simple. Yep, and in that case, if it doesn't specifically say that it is rated for 2 or more conductors, you have to assume that it is not and go with the more limiting approach. Before we wrap up, let me talk to you about money on this job. See, our contract on this job is about 40 grand all in. We got hit. We quoted up this job almost 2 years ago and we got hit with commodity increases. The price of copper has increased about 300%. The price of PVC about 500%. And so the fact that this project has been so prolonged, starting during the pandemic, and now here we are in the middle of 2022, so prolonged, that's really eating into our profits because all of our costs have increased substantially. Now, we did present the general contractor with a $4,000 commodities adjustment change order that was processed and approved and paid out. So man, these guys are good to work for. Well, we are at the end of a tiring day. I can feel it in my muscles. We have just concluded the 1200 amp service to the $1.5 million pool house. That's right. Click here for our next video and subscribe to Electric Pro Academy for more real skills to make